Now this question is related to dissociation of H3PO4. Basically in lectures we discuss this problem in details. Half of the lecture we explain the concept of this problem. So we are not going to explain this problem in details. I will assume you have already covered the lecture, you have attended the lecture, so I will give you the solution in brief. Even if you have not attended the lecture, but you have a slightly some knowledge about this, you can get the answer. So let us say this question says, calculate the concentration of all species of significant concentration that is present in 0.1 mH3PO4. So I have 0.1 mH3PO4. Are you getting? So what are the species that is present in 0.1 mH3PO4? And for hint I have been given for this reaction, K1 is given to you 7.5 into 10 to the power 3, let me see, minus 3. K2 is also given to you. This is 6.2 into 10 to the power minus 8. K3 is also given to you. That is basically equals to 3.6 into 10 to the power minus 13. You have to calculate the pH also. So what are the things that you have to calculate? A space is present. So what are the spaces, major spaces you have to calculate? So concentration of a species. So what are the concentration of different species? And second thing you have to calculate, that is basically pH of the solution. So what is the pH? So you have to also calculate the pH. So two things basically you have to calculate. And now how will you proceed? Those who have already know the solution, please let us think for 1 minute. Tune your mind so that you can have a plan. How will you proceed for this question? So try to make a rough sketch in your mind. No need to write anything. Just simply think in your mind how you are going to solve this problem. So let us take 1 minute time. Okay, let us discuss. Basically H3PO4 is a tri-basic acid. So what will happen? You will have first reaction. H3PO4 will dissociate and it will give you H plus H2PO4 minus. So this is the first reaction. Next reaction you will have H2PO4 that is coming from the first step. It can further dissociate, and if it happens, you will have H plus HPO4 2 minus, and HPO4 2 minus can further dissociate, and in that case it will give you PO4 3 minus. So let me first write H plus PO4 3 minus. Equilibrium constant for this is K1, this is K2, and this is K3. Now what are the assumptions that I am going to make is, this is 0.1 m. So first assumption I am going to make is, equilibrium constant, this is 10 to the power minus 3. So this is, so let me write the equilibrium constant also, 7.5 into 10 to the power minus 3. This is 6.2 into 10 to the power minus 8. And this is 3.6 into 10 to the power minus 13. So these are the equilibrium constant. And our first assumption I am going to make is, the H plus that is coming is only coming due to the first reaction. H plus will come from the second, H plus will also come from the third, but the equilibrium constant is so small that the H plus that is coming from this and this can be neglected. So if I neglect the H plus coming from equation 2 and equation 3 with respect to equation 1, now I can say H plus is coming only from equation 1. So let us call this is equation 1, this is equation 2, this is equation 3. So now the first assumption I have, H plus is coming only from dissociation 1, coming from first dissociation. In a good language of chemistry, I can write first dissociation. This is the same as our first equation. So now let us see, I can solve an H2PO4. The second assumption I am going to make is, now H plus will come and H2PO4 will also come, but the H2PO4 will further react in the second equation. So some of the H2PO4 will remain in the solution, but some of the H2PO4 will go into this reaction. So let us say if this X is coming, here also X is coming, but some of the X that is going to react with this equation. Now the second assumption I am going to make is, so what will happen? So let us say bi reacts in this case. So you will have bi here, you will have bi here, and X minus bi, because H2PO4 either you write here or you write here, you should be write X minus because H2PO4 2 minus is in the solution, H2PO4 minus is in the solution. Now the second assumption I am going to make is, second equation equilibrium constant is so low, so I will assume that the second equation H2PO4 that is coming from the first equation very less going through this dissociation. So I will assume that is the mathematically y is much less than X. So the second assumption I have, HPO4 2 minus concentration does not changes by equation 2 or by second dissociation, second and third dissociation also, because in the third dissociation this comes, this goes here, and this can further react. So I can say third dissociation also pulling the second, and second is pulling the first. But I am saying third dissociation and second dissociation is not going to change the concentration of HPO4 2 minus. So HPO4 2 minus concentration does not change by second and third equilibria. So now things are very easy. So I have the first equation, so concentration of H plus is equals to either here, concentration of H plus is equals to concentration of H2PO4, because this by is almost 0, this by is 0, so concentration of H plus into this divided by 0.1, and also this will be basically 0.1 minus X. So third assumption I can make, this X is very small with respect to 0.1, so I can say 0.1 minus X is approximately equals to 0.1. Are you getting? So these are the three assumptions. If I apply these three equations, I can write for first X squared divided by 0.1 minus X, that is basically 0.1. This is equals to K1, 7.5 into 10 to the power minus 3. Now if I say, so this will 7.5 into 10 to the power minus 4 under root. So I have to take the root of 7.5 into 10 to the power minus 4. So this is, I think you are able to see or not. So 7.5 into 10 raised to the power minus 4, and I have to take the root of the answer. So root of answer, this is 0.0273. So this is 0.027. If you want, you can write up to third decimal place, 0.0273. So this is the concentration of H plus. What is the X? X is nothing but concentration of H plus. Now I can here itself I can find pH, because H plus I said only coming from the first step. So if I take the log of the answer, this is 1.56. So pH will be 1.56. Are you getting? So this is my first assumption. Basically here I can check if I am writing 0.1 minus X, basically this was the 0.1 minus X. 0.1 minus X is equals to 0.1. How much error I am doing? So error is, X is this. So let us calculate percentage error. Let us check 0.0273 divided by 0.1 into 100. So this value will be how much? So this is 0.2, and this will be, I think, 27%. So let me check. 0.0273. So I have 0.0273 divided by 0.1 into 100. So this comes out to be 27%. This means my assumption is not valid. Are you getting? If the solution is dilute 0.1 m, my assumption is not valid. The third assumption, that is, I cannot write 0.1 minus x is equals to x. So this means error is 27%. So this means I cannot write 0.1 minus x is equals to 0.1. I have to solve the equation. I have to solve a quadratic equation. Now I have a difficult task to solve. So let us try to solve this quadratic equation. So my assumption is not valid. So let us write. So generally we will have a valid assumption. Here things are slightly complicated. So assumption is not valid. So let us write. Assumption 0.1 minus x is approximately equals to 0.1 not valid. Are you getting? So I have to solve again. I have to solve the quadratic equation. Slightly difficult task. So I have 0.1 minus x square divided by 0.1 minus x. This should be equals to Ka. Ka is 7.5 into 10 to the power minus 3. So let us try to solve. X square is equals to 7.5 into 10 to the power minus 4 minus 7.5 into 10 to the power minus 3x. So x square plus 7.5 into 10 to the power minus 3x minus 7.5 into 10 to the power minus 4. This is equals to 0. So this is my quadratic equation. For me this is easy because I can use my calculator. So minus b 7.5 into 10 to the power minus 3 plus minus, there is no need to take the negative root. Practically negative x value for negative is not possible. B square minus 4ac. So minus minus plus. So 4 into 7.5 into 10 to the power minus 4ac. This divided by 2a. So now let us take the positive and try to find what is the solution. So I will use my calculator. So 7.5 into 10 raised to the power minus 3 and this whole square plus 2 into 7.5 into 10 raised to the power minus 4, and I have to take the root of this. So root of answer plus, because negative root I cannot take, basically I have to subtract this one. So let us say minus 7.5 into 10 raised to the power minus 3, this divided by 2. So this is 0.159. So this value x is coming out to be 0.159. So this is my concentration of H plus. Are you getting? So let us calculate so this is H plus. If we calculate pH, let us check whether we have done right or not. Basically there is a mistake, I think, because answer is coming out to be 0.024. Let me check once again this. So this calculation, let me check once again. I have done some mistake. So 7.5 into 10 raised to the power minus 3, 10 raised to the power minus 3, and this whole square plus 4 into 7.5 into 10 raised to the power minus 4, and I have to take root of this, and minus 7.5 into 10 raised to the power minus 3, and then I have to divide by 2. So this comes out to 0.0238. Basically there are some mistake in the last calculation. So this is 0.0238. So H plus is around so I can say H plus is around 0.0238. Now I can take pH, so log of this, so pH will be, I have to take log. So if I take for log for answer, this is 1.62. So pH will be 1.62. Are you getting? So we have calculated the concentration of H plus, and we have also calculated concentration of H2PO4 minus, you see. So what will the concentration of H2PO4 minus? That is same as X. So now I can say concentration of H2PO4 minus, that is also equals to 0.0238. And what will the concentration of H3PO4? This is basically 0.1 minus X. So 0.1 minus 0.0238. So this value comes out to be, so let me check, 0.1 minus 0.0238. 0.0238. This is 0.076. So 0.076. Are you getting? So please keep copying. Now next part can be easily found. So what is the concentration of HPO4 2 minus? We can calculate easily. So you see H2PO4 minus, the second equilibrium you have H plus HPO4 2 minus, and equilibrium constant for this reaction is, now I know the concentration of H plus. H plus is, you see in the first part, 0.0238, and H2PO4 minus is also 0.0238. So concentration of this is simply same as, so I can write 0.0238 into HPO4 2 minus, this divided by 0.0238, this is equals to K2. So this is simply equals to, so now I know concentration of HPO4 2 minus is equals to K2, and the value of K2 is 6.2 into 10 to the power minus 8. So you see the concentration of HPO4 2 minus is so small, and that's why we have neglected the Y that is coming from the second equilibrium. So you see this value is 0.0238, and even from this, even if you remove this much 10 to the power minus 8, this value is not going to change, and that's why you see in the last question we said the Y is very less than X, and that's why my assumption is now right, because Y that is coming 10 to the power minus 8, and this is something of 10 to the power minus 3. So there is no point of subtracting 10 to the power minus 8 in 10 to the power minus 3. Now let us see the third equilibrium. So you have HPO4 2 minus, and third equilibrium will have H plus PO4 3 minus, and now I know the concentration of HPO4 2 minus, that is 6.2 into 10 to the power minus 8, and H plus concentration is 0.0238. So I can calculate this concentration because K3 is given to you, 3.6 into 10 to the power minus 13. Now using the equilibrium expression, you can calculate the concentration of PO4 3 minus. So let us try. You will have PO4 3 minus into 0.0238 and divided by 6.2 into 10 to the power minus 8. This is equals to 3.6 into 10 to the power minus 13. So from here you can calculate the concentration of PO4 3 minus. Are you getting? So PO4 3 minus will be 3.6 into 10 to the power minus 13 into 6.2 into 10 to the power minus 8, and this divided by 0.0238. Are you getting? So let me calculate this value. So I have to calculate this value. So I think you can be able to see this one. So I have to multiply 3.6 multiplied by 6.2 divided by 0.0238. This value comes out to be 937.8. So 937.8, and this is 10 to the power 13 or 8. So you will have 10 to the power minus 21. So you can also write 9.37 into 10 to the power minus 19. So this is the concentration of PO4 3 minus. Now you see we have basically calculated the concentration of all the relevant species. So the concentration of PO4 3 minus is so small, 10 to the power minus 19 is insignificant. It's very difficult to judge such concentration. So you can say this is a insignificant concentration, very small. But still one can ask, let us find this concentration. Even this is a small one can ask to find. So that's why insignificant concentration. I think all of you have copied this one. If you have copied this one, then I can go for the next problem. Please do fast if you have not copied. These are. So you see, if you have a tri-basic acid, the question can be solved by exact method also. That is, someone can solve 3 equation, 3 unknown, but that is not a good idea. You have to make the assumption. Assumption is H plus comes only from the first step, and the second assumption is the equilibrium 2 and equilibrium 3 can be neglected with the equilibrium 1. That is another assumption. And another assumption, that is 0.1 minus x can be written as 0.1, and you have to verify this assumption also. In this case, that assumption was not right, so I have solved the quadratic equation. That is basically solving the solution part. So sometime you can solve the quadratic equation if the assumption is not valid. Otherwise, your assumption is valid, then you don't have to solve the quadratic equation. Let us go for the next problem.